Um, so this is the talk about PLM. I'm going to start with just kind of a quick introduction about me. My name is Chris. I've been working as a hardware designer for about a decade. Did a brief stint in PCBA manufacturing, and then kind of came back to doing design work. I started a consulting firm, Common Ground Electronics, where I do a lot of IoT-related stuff. Want to just do a quick kind of logistical note here. This is a link to the slides, and eventually this will also have a link to the video once it gets posted. So you don't have to take pictures of all the slides as we go along. You can just grab a copy of them here if you want to review them later. And I'll come back and show this slide again at the end of the presentation. So quick kind of poll of the audience. How many of you know what PLM is? And for those of you that know what it is, how many of you, does it give you the warm and fuzzies? How many of you dislike it? I'll put it that way. Yeah, so I think PLM in general has kind of been associated with like large enterprises, and it feels, I think, very complicated or inaccessible to a lot of people. And so I think one of the things I want you to take away from this talk is that even if you're a maker or a hobbyist or a small business owner or a consultant, there's some kind of core aspects of PLM that I think are actually really helpful, and they don't have to just be applied in like the enterprise environment. And we'll go over all of those things and a kind of like what a working definition of PLM is for the rest of this talk. So I want to start with this quote here. This is called Gall's Law. You might be familiar with it. It says, "A complex system that works is invariably found to have evolved from a simple system that works." And so that's what this talk is about. It's basically my kind of exploration into, can I set up a simple system that works for PLM using KiCad, and also that works for doing open source designs. And I think that's kind of a unique kind of take on this, because most companies or organizations that are using PLMs aren't really interested in doing this for open source designs as well. Okay, so a couple goals for the talk. PLM, like I mentioned, can be a pretty complex topic, and we've only got 50 minutes. So I think that there's kind of two high-level goals. One is that you should be able to replicate everything we talk about in a weekend. So this should be pretty relatively straightforward to set up, and I'm going to walk through an example where we integrate KiCad with a specific PLM tool called Aligning, and that's an off-the-shelf commercial product that is already available that you can just pick up and start using. Not going to cover every aspect of PLM, and I don't really have time to compare and contrast multiple PLM systems, so we'll kind of focus on the specific example, but that should be applicable to other PLM systems or other CAD tools if you're looking to kind of apply the principles. So we'll get started with what actually is PLM. PLM stands for Product Lifecycle Management, and Product Lifecycle Management is a process that combines best practices and software tools to centralize and structure product information over the course of the product development lifecycle. And that sounds like a mouthful, but we'll walk through kind of what each of those individual pieces are. So when you design a physical hardware product, that product goes through a product lifecycle. It starts with defining the requirements for the product, a series of validation and testing phases, and then you ramp that product up to mass production, and eventually it goes through sustaining and end of life. And over that life cycle, the hardware goes through multiple iterations of this design, build, test, and learn cycle. And those iterations generate a whole bunch of data about that product that needs to be managed. You'll have part numbers, revisions, you have CAD files that are being generated, manufacturing documents. There's a lot of suppliers and vendors that need to be managed for all the components that go into the bill of materials. And there's all sorts of regulatory compliance processes and documentation that are also involved in each of those iterations. So where does this data end up? And I think for most people in this room, and me personally in the past, a lot of this stuff has ended up either as values in a KiCad schematic or in spreadsheets or folders on your computer or Google Drive. It's kind of spread across a lot of different places. And that's not really ideal. I think you really, when that data is spread across these different places, or if it's stored in KiCad, that data becomes siloed. You can't easily access that product data or that supply chain data from other tools unless you're parsing the files. There's no API for KiCad that will let you extract that data out. And then once it's stored in those static places like a KiCad file, that data can become quickly outdated. So you can have manufacturers that get purchased, the name of the manufacturer changes, and the data that's stored in your KiCad files can just become outdated over time. And it's also easier to make mistakes when you're manually putting this data in for each design or copying and pasting things from one design to the next design. This is an example where we copy and pasted something wrong and built the board with SPI version of the chip instead of the I2C version, and SPI bus didn't work. So I think everybody's kind of experienced those type of copy-paste errors. So there's got to be a better way to do this. Hopefully there's some Friends fans in the room. The kind of ideal, what we want to approach here is that your CAD files are really reflecting the design intent, and then the manufacturing implementation is decoupled from the CAD files. So CAD is kind of this evergreen thing that should always be correct, and then as the manufacturing or supply chain information changes over time, that's managed outside of the CAD files in a separate tool, like a PLM. So people realized this was an issue and a problem that could be solved with software, and so they built PLM tools. And there's a whole bunch of these that exist today from different vendors for different industries, and there's a lot of options here. So what does PLM software actually do? It's intended to be a centralized single source of truth for all of your product data. So it manages part numbers, it manages revisions, your bill of materials for assemblies, sometimes it does document control. And the other thing that it does, because it's centralized, it allows product teams to access this data. So if you're working with a team that has designers and product managers, they don't need to have accesses to KiCad to go open the files to look at who the vendors are, who the suppliers are, what the manufacturer part numbers are for this product. All of that information can be stored within the PLM tool that can be accessed by other members of the team. And then it also does things like change management. It has auditable change histories, and it integrates with other systems like PDM, MRP, ERP, MES. If I'm babbling along and you have no clue what I mean, that's, I think, an appropriate picture. Most people kind of feel that way when you just start rambling off these three-letter acronyms and it starts to feel like kind of enterprise gobbledygook. So we'll do a quick, less than 10-word introduction to each of these things. Product data management is typically an engineering tool that's used to version and manage typically CAD design files. Product lifecycle management grew out of PDM over time, and it became this kind of central hub for product data, approvals, and managing the overall lifecycle for a product. And then on the manufacturing side, you have material requirements planning, MRP software. That's typically used for things like inventory management, purchasing, demand planning, kind of all of the managing of builds within a factory. And then ERP is kind of the 900-pound gorilla in the room. That's kind of an extension of MRP and usually will manage your entire business process. So that has tools for managing supply chain logic across departments. You have finance and HR. And if we kind of look at how these different tools relate to each other, you'll see that PDM is typically a subset of PLM. So PLM typically includes PDM as part of the tool. And interestingly, more recently, KiCad has been using Git for some of the functions of PDM. So you're seeing designs stored in GitHub repos or GitLab or other Git type of tools. And then MRP is typically a module that you would purchase as part of a larger ERP installation. And when these tools are integrated together, part and product data flows from PLM to MRP kind of back and forth. So for example, if you're going to schedule a build in an MRP system, you would have your part numbers, your manufacturing bill of materials flow from the PLM system into the MRP module in the ERP system. Okay, so you kind of have a picture now of like what PLM is and how it fits into the kind of broader ecosystem of these style of tools. We're going to talk specifically about how to set up a workflow between KiCad and Aligny, which is a specific PLM tool. And there's a couple outcomes that I'll go over first here. These are kind of what we're working towards as part of this overall integration. So the first thing that we want is for part and supply chain data to be stored within the Aligny database rather than within your KiCad files. And then the second aspect of this is once you have all of that rich part data and supply chain data stored in Aligny, you can actually use that to automatically generate libraries that you can use in your KiCad designs. So you don't have to manually create a resistor for every part number. You can create a resistor template symbol and then use all of the part data in Aligny to automatically generate libraries with thousands of resistors, thousands of capacitors, all the parts in your system. And then the last aspect here is that once you've designed a schematic PCB assembly in KiCad, we want to be able to export the bill of materials from KiCad, import that back into Aligny, and then automatically populate the bill of materials for the PCB assembly. So quick introduction to Aligny. Aligny is a tool that combines both PLM and MRP functionality into a single tool. So it'll do your part number management, your bill of materials. It'll also do inventory and supply chain management. So it has a lot of that functionality very tightly integrated and kind of combined within a single tool. And the functionality that's provided by Aligny, it has a part database that they call an item master. This is like the core database that stores all of the part information. It also has tools for engineering change management, quality workflows. It'll do, like I said, inventory management, supply chain stuff, and it'll also let you manage manufacturers and vendors and even do some customer management as well. So this talk is specifically about the part database piece of Aligny. This is the reason why I'm going to cover this is because this is typically the first thing that you would set up if you're setting up a PLM system. It's kind of the core functionality and the core database that has all the information that's used by the other parts of the tool. And then it also provides all the information that you would need to generate the KiCad libraries for placing those parts in your schematics. Couple notes on why Aligny. There's a lot of options for PLM tools, and I ended up going with Aligny for this talk because I wanted a simple solution that didn't require a whole bunch of kind of complex setup. I wanted something that you can take and go home and spend 2 or 3 days and you're completely set up and not have to hire consultants or onboard a giant PLM system. I also wanted a tool that kind of had a way to support KiCad's database libraries feature out of the box without having to do any custom development. And I also wanted something that was ECAD agnostic. So as a consultant, I want to be able to use Altium or KiCad with the part information and not be tied to a specific CAD tool. And I also wanted something that I could play around with for a while without paying for it first. So Aligny has a free tier for open hardware, and it actually also has public access. And this goes back to that open source design aspect that I was trying to achieve, which was you can actually access part data from Aligny for these public open source designs without having to create a login, without having to be provided special access. You can just open a page and see all that part information for any public design that's shared within the tool. And then also wanted automatic management for part numbers. Some of the other tools available have free tiers, but they don't let you manage internal part numbers as part of the free offerings. So the way that you get set up, you go to this page here in the slides, app.aligny.com/catalog. This will show you a list of all of the public open source organizations on Aligny, so you can check out other organizations or companies that are using this to share their designs publicly. You create a new organization, and it's going to ask you whether you want a private organization or a public organization. I recommend starting with a public one because it's free and you don't have to pay for it. You can play around with it for a little while. And then if you do decide that you need things to be private, or you go beyond the free tier usage limits of the public ones, you can always switch back to a private org. So this is what you'll see when you log in. It's the Aligny dashboard. It shows the item master right here, links to being able to manage parts, and then it has all the other functionality that I mentioned before. And so like I mentioned in this, we're going to be focusing just on setting up the item master piece of this, and then that will be used for the KiCad library generation later on. So the item master, it's basically your single source of truth for part data that can be used in other systems like KiCad or integrated with your MRP or ERP if you have those. It manages part numbers, descriptions, specs, and manufacturers, and it's backed by a normalized relational database. And so what that means is that if you have parts that link to a specific manufacturer in the system, they're not just kind of text copies of the manufacturer name, but you're actually getting links back to a manufacturer record. And if the manufacturer's website changes or the name of the manufacturer changes over time, those parts will always have up-to-date information linked to them about the manufacturer or suppliers for those parts. This is what the parts page looks like for a part in Aligny. So there's some kind of core part details here on the left-hand side. It has all the stuff you would expect. A part number that's generated by Aligny, linked to a manufacturer record, manufacturer part number, and then a bunch of additional parameters that can be either customized for different types of parts or standardized across your entire library of parts. It also has the ability to do alternate part relationships. So if you have one part from Jaego and you have another resistor that has the same specs from Samsung, you can set up the tool to say, hey, these two parts are equivalent relationship, and the tool will be smart about knowing which parts are replaceable within your designs. And then this last piece here talks about where this part is used in other assemblies. So if that part gets included in the bill of materials for different PCBAs, it'll show up in a list of the assemblies where that part is actually being used. Aligny also will let you track revisions to parts. So this is how you track changes to individual parts over time. And then it will also do things like inventory management. So in this example, we've got, it's showing that there's stock of this part at JLC PCB. There's 1,000 resistors available. And also it shows the inventory cost for those parts as well. And then finally on the supply chain side, it allows you to define one-to-many relationships between a part in Aligny and the suppliers that you buy those parts from. So here you can see there's a part that can be bought from DigiKey or Mouser, or Newark, or LCSC, the supplier's part number for each of those parts, and you can manage those supplier relationships within the tool. So in order to kind of get all this information in, you've got to be able to create parts within Aligny. And there's some initial steps that you need to kind of set up before you can start adding parts to the tool. The first thing you need to set up is a part number scheme. So I recommend that you start with a non-intelligent part number scheme, something that doesn't encode like the part type or part values within the part number. And I recommend using the auto increment feature in Aligny. This will automatically generate those part numbers for you. And the reason why I say non-intelligent is with like a 6 to 7 character limit is that the human brain can only remember up to about 6 or 7 digits before you start having to kind of forget characters and have to go back and double check things. And I've seen cases where intelligent part number schemes kind of fall apart. So if you don't have any specific requirements that are driving you towards a different type of scheme, I would recommend just using a simple non-intelligent numeric part number scheme. And then the last thing here, you'll have to set up a set of custom parameters. These are additional parameters that show up for the parts that you can add for custom specs. In this case, there's a text field that we're adding called KiCad symbols, and we'll use this field later on when we generate the database libraries for KiCad to use for generating the part symbols. Additionally, I mentioned that there's this concept of part types within the tool. Part types are essentially ways of grouping together sets of parts that are similar to each other. So you can have a chip resistors part type, chip capacitor part type, and then the part types are what define the behavior and the set of custom parameters that show up for each of those types in the system. So you can say chip resistors have a power rating parameter that doesn't show up for other parts because they're not part of that part type. Okay, so once you've added these parts to your library in Aligny, it would be really awesome if we can actually just generate our libraries automatically rather than having to create them manually in KiCad. And so this next section we'll talk through actually how to use the database libraries feature in KiCad to generate those automatic libraries of parts. So KiCad has this really cool feature called database libraries. What it is it's a feature that talks to a SQL database, and it looks at a specific set of tables in that database where part data is defined, and for every row of part data in that database, it will read out the data, look for the associated KiCad symbol as a template, and optionally a KiCad footprint, and it will merge that part data from the database into that part symbol and automatically generate a part in a KiCad library for every row in the database. So to get that working, we need a couple different things. We need a database, we need a database library config file, and then we need KiCad symbols to use as templates, and optionally KiCad footprints if you want to link footprints to those parts as well. Okay, so first thing we need is the SQLite database. Instead of creating this manually, Aligny actually provides a Windows application that they call the replicator. And what this will do is it will automatically synchronize your Aligny cloud item master with a local SQLite database on your PC. So this will generate that SQL database for you, and you don't have to kind of manually maintain a database for KiCad to use. And you can download that from the link at the bottom of the slide. If we look inside of that SQLite database, you'll see that there's a parts table that has all of the parameters that are defined in the Aligny item master. And then if we look at the actual data in the parts table, you can see these are all the parts that we've defined within Aligny, and we've got the part number that was automatically generated by Aligny for all of those parts. One thing that you will need is something called an ODBC driver. KiCad doesn't actually talk directly to databases. It uses this industry standard API for talking directly to a lot of different types of SQL databases. So you can download the SQLite ODBC driver from this link in the slides here, and KiCad will use that to talk to SQLite, or if you have other types of databases that you want to use, it'll also allow you to talk to other different types of database management systems. And if you get everything installed, you should see, I have examples for Windows and Mac OS. You should see the SQLite ODBC driver showing up in this data source administrator application. The thing to note here is the name of this driver, because when we get into actually configuring the setup in KiCad, you'll use that exact name as part of the string for setting things up in the KiCad configuration file. Okay, so the next thing we need is this database library configuration file. It ends in, the file extension is KiCad_DBL. And this is just a JSON configuration file that maps tables and fields from the database to the KiCad libraries and symbol fields on the KiCad side of things. So this is typically how I kind of lay out the directory structure for a library that's using this setup. I have a folder called databases that has the SQLite database, and then under the symbols folder, the KiCad database library configuration file. And the reason I put it in the symbols directory is because later on you're going to add this to the KiCad symbol library table, just like every other symbol library that you would add in KiCad. And this is a simple enough file that we can actually just take a look at the whole thing here. The beginning of the file, there's kind of two things to pay attention to. One is the type of database connection that we're going to be using. This is an ODBC connection to the SQLite database. And then this connection string here says we want to use a driver with the name of that driver that we previously installed. And the database connection, the file path to the database is the link to the path to that SQLite database that's generated by the replicator application. The next part of the database configuration file is setting up the library mapping. So this says use the parts table from that SQLite database, and then the unique key for every part or every row in that database, we want to use the part number field that's generated by Aligny as that kind of unique identifier for each part. And we want it to use the symbols and footprints defined from these KiCad symbols and KiCad footprints columns in that database. One thing to make sure is that any symbols that you reference or footprints that you reference in those database fields need to already be defined in the library table for your KiCad installation. So if you're referencing those template symbols, they need to already be populated here. And here's what it looks like for one of these template symbols. So in this case, we have a template for a resistor with placeholder fields that are going to be populated by the database. It'll populate the value, the internal part number, the description, data sheet, and any footprint that you want associated with that part. But you'll notice here there's no supply chain details in that symbol template because that IPN is what's going to map back to the manufacturer, the part number, the suppliers, all of that part data that's stored within Aligny. So this next section just maps those individual fields over. You can see we're mapping the display value from Aligny to the value field in KiCad. The part URL from Aligny gets mapped to the datasheet field in KiCad. And this is actually a nice integration where if you're working in the KiCad schematic editor or you generate a PDF, you'll be able to just hit the D key. It will pop open a web browser directly with a link to that Aligny part, and you can see all the part information. So you can quickly move from KiCad back to Aligny. There's one kind of caveat here, which is the part URL that we use for that functionality isn't actually included in the Aligny replicator by default. So there's kind of two ways to approach this. One is you can just add a field in the Aligny part, which has a link to that part. And the other option is there's some slides later on which will talk about a SQL solution to automatically adding that additional column that you need without having to add that separate field within the Aligny database. And then the last thing here is just mapping the part number column to the IPN field in that KiCad symbol. There's also some mapping between additional fields from Aligny's to KiCad properties. So it'll pull in the description for the part, any keywords that you have defined in Aligny, and then whether or not to exclude that part from the BOM, the board, or the simulation. When you're done setting up that configuration, that JSON file, you just simply add it to the KiCad symbol library table, just like any other of the symbol libraries that you're used to using. And you'll see the type of database file format will be shown as database here instead of KiCad. And that just gets set up automatically. And then once all that's set up, you can go into KiCad, hit the place parts symbol in the schematic editor, and you'll have an automatically generated library in KiCad with all of the parts from your Aligny database. So this will be pre-populated and just generated on the fly every time you go and place a part in your schematic. And as you can see here, we've got the footprint defined, a link back to the part in Aligny, the description, and the internal part number for that part. This is cool because it allows you to do part searches a little bit more intelligently in Aligny. So instead of just using the filter field in KiCad, you can actually go in Aligny and say, show me all the resistors with value between 100 and 200 ohms with 5% tolerance and whatever other kind of custom search parameters you want. And you can do very kind of fine-grained searching within the tool. And then once you've got the part number that you're looking for, you just hop back into KiCad, punch that part number in, and it will filter everything out, and you can place that part in your schematic. Like I mentioned, this also generates nice links in the exported PDFs. So if you generate a PDF for an open source design, you can somebody can open that PDF, click the link in the PDF, and it will automatically open that page in Aligny. And there's no login, there's no access controls. You can basically just view those parts and all the part data without a lot of overhead. And then finally, I'll walk through kind of an example of once you've finished a design, how do you import that back into Aligny to generate the bill of materials for the PCB assembly. So this is just an example using a really simple dummy board that I created. I wanted to be able to fit the whole BOM on one slide, so it's really simple. But the important thing to notice here is that when you export this CSV from KiCad, all of the internal part numbers are populated, and Aligny will use that as part of the import process. There's a mapping step where you map the part number in Aligny to the part number field in the CSV, and when you import that BOM into a PCB assembly part, it will automatically match all those parts in the CSV to the parts that you've created in Aligny and create this nice bill of materials with all the parts populated. So you don't have to go back and manually manage a bill of materials separate from Aligny. You can just import that BOM over and over again until you're happy with it, and that will stay up to date in Aligny. So there's a couple limitations to point out with this workflow. The first is this kind of a small limitation where KiCad has the ability to, if you have a database that's got multiple tables in it, KiCad can generate a separate library for every table. And so one use case would be you have a table for resistors, a table for capacitors, a table for other types of parts, and KiCad would generate separate libraries for each of those part types. Aligny only has a single parts table in the replicator database, so you won't be able to get separate libraries in KiCad split up by their part types. The second limitation is that there's currently no way to assign multiple symbols to a single part. So if you have a part in Aligny for an M.2 connector, and you want to be able to, in KiCad, have separate symbols for that same part, you can't have a generic symbol or another symbol for the micromod standard with different pinouts, or another symbol for PCI Express with yet again different pinouts. There's only a way right now in KiCad to assign one symbol to each database part. And there's an open issue here to add that functionality into KiCad to be able to select multiple different symbols for the same physical part in a database library. So this is a similar issue. There should be a way to assign multiple footprints to a single part, but when I actually sat down and tried this, I ran into some bugs that prevented this from working. So there's another issue you can kind of keep track of here. For that, it should work when the developers fix the issues. And then finally, there's some limitations with Aligny's free tier. So one big limitation is that it's currently limited to having 1,000 parts in the free kind of open source organizations. If you go beyond that, they want you to switch to a subscription model where you pay kind of a monthly fee. So if you do know you're going to have large libraries beyond 1,000 parts, this could be a limitation for you. I think I'm pretty close to time here, and I want to leave time for questions. So there's some additional tips in these slides. One is talking about how to, if you want to store that SQLite database within a Git repository, there's a little bit of trickiness to that. You can download the slides and read through this, but I talk about how to do that. And then also how to add that part URL column into the SQL database if you want to use a SQL command to do that. It's also possible using Python, using the SQLite 3 package. And then there's some additional slides in here about how to use revisions correctly, or best practices for using revisions within a PLM tool. And you can go through those slides offline. Let's see here. Yeah, so I think I'll stop it there. Any questions?
So this is super useful, and as a individual who has made the bomb error of like, oh, I updated the value field, but I did not update the MPN, and as a consultant whose clients have done that on really expensive boards, I was always wondering what the right answer was for solving this. And so I enjoyed and especially being able to see in Aligny like the part view. And the part where I started to become somewhat suspicious was when the solution involved having a Windows VM that runs a database and wiring up a database driver to a local SQLite database that somehow mirrors a cloud thing. So I guess one, are there any, even if they're less featureful PLM solutions that are open source? And maybe for like 1 or 2 person things, is there something that does not involve a Windows VM that runs is there something that's more closely integrated with KiCad even if it's less featureful?
Yes. So to answer your first question about non-Windows VMs and local databases, I mentioned this because this is kind of the easiest way to get set up quickly, where you don't have to manage your own database. But Aligny also has an API, so if you are comfortable programming, you can write your own client for the Aligny API that will integrate with KiCad's HTTP libraries feature and kind of act as a translation between the Aligny API and what KiCad expects on the HTTP API side of things. So that's one option. I've done a prototype of that with Python, and it's totally a workable option. It's just requires some custom development, and it isn't something that you can kind of quickly get set up and sitting down for a day and kind of trying this out. And then you mentioned open source or like other simpler options for PLMs. There's a tool called Inventory, which is an open source inventory management tool that has a lot of PLM and MRP functionality kind of combined together. And there's another tool called Git PLM, which is kind of a simple tool that stores this type of part information in CSV files. Where you can also store in a Git repository, and then it will do something similar. It will kind of rehydrate a SQLite database based on those CSV files.
Cool. Yeah, I'll have to Git PLM. Sounds really interesting. That
Cool.
sounds like about the level that I'm looking for.
Yeah. Okay.
Thanks.
Not a question, but just to chime in, but I'm also working on another PLM-like system. So,
Oh, awesome. Yeah, I'll definitely chat with you afterward.
yeah, no worries.
In Aligny, you showed the supply chain aspect of it. Are those all just built in, like the various, like Mouser, DigiKey?
Yeah. So actually, if we go, I can take a look here. Oh, I don't have internet. Yes, there are some. Let me go back to the slides. Where was that? Supply chain. Here we go. Yeah. So these Aligny will automatically generate nice links to the part pages on the distributor web pages, but only for DigiKey, Mouser, and Newark. And the reason for that, I think, is because of the way the URL structure is for those sites. It's easy to just have like a template string that you stick in the part number for. For some of the other vendors, they don't have nice URLs that are easy to kind of automatically generate. And so, for example, you can see LCSC here. They don't have an integration with LCSC that generates that nice link to the part. So you just have to copy and paste it into LCSC.
So the LCSC line there, you imported it entirely, or it was there but you just can't click through it?
Oh, sorry. Yeah. So these are all manually added. So
Okay.
you could write a tool that would automatically pull like a part from the DigiKey API and stick that into Aligny via their own API, but you'd have to create that glue code to pull one part from one place and stick it in the other. And this is just all manually added by hand.
Okay, thank you.
Okay. Thank you.